Good morning, students. Yesterday I was talking about eigenvector, eigenvalues, and eigenvector. As I have said, a non-zero column vector x is said to be an eigenvector of a square matrix A if it satisfies the equation Ax equal lambda x, or Ax equal lambda I into x, because I into x is x. Any matrix multiplied by a unit matrix is matrix itself. So, or A minus lambda I into x is equal to 0. A is a unit matrix of order m by n. Lambda is the eigenvalue. I is the unit matrix. X is the column vector. This is which is known as the eigenvector, and 0 is the zero matrices. So, a non-zero column vector x is said to be, because 0 is always the solution, so a non-zero column vector x is said to be an eigenvector of a square matrix A if it satisfies this equation A minus lambda I into x is equal to 0. What's A minus lambda I? Which we have seen it yesterday. A minus lambda I is known as the characteristic matrix. And what is lambda? Lambda is the eigenvalue. What is the eigenvalue? This is root of the characteristic equation. So in order to find lambda, we have to find the characteristic equation. And this is the characteristic matrix. This is the eigenvector. Okay, let me take up few examples. Let me begin with simple example. A equal to 1, minus 2, minus 5 and 4. This is square matrix of order 2. Then we have to find the eigenvectors. Now let me tell you, we have to find eigenvalues as well as eigenvectors. So for eigenvalues or eigenvectors, I have to first find the characteristic matrix. The characteristic matrix of A is given by A minus lambda I, which is 1 minus 2 minus 5 4 minus lambda I 1 0 0 1, or 1 minus lambda minus 2 minus 5 4 minus lambda. So this is the characteristic matrix of A. The characteristic equation of A is what? Determinant of lambda I is equal to 0. That is determinant of 1 minus lambda minus 2 minus 5 4 minus lambda is equal to 0. Determinant of this is equal to 0. This gives 1 minus lambda 4 minus lambda minus 10 is equal to 0, or 4 minus 4 lambda minus lambda 5 lambda plus lambda square minus 10 equal to 0, or lambda square minus 5 lambda minus 6 is equal to 0. This is known as the characteristic equation. Characteristic equation of A. What is lambda? The lambdas are 5 plus minus 25 plus 24 by 2 means 5 plus minus 7 by 2. So 5 plus 7, it is 6. 5, it is minus 1. So lambdas are minus 1 and 6. These are known as the characteristics values of A or eigenvalues of A. This is the characteristic matrix, as you have already seen. This is the characteristic matrix. This was the characteristic equation, which turns out to be a quadratic, because this is a square matrix of order 2. Square matrix of order 2. So we have a quadratic. Therefore, 2 roots of lambda, which are known as the eigenvalues. Characteristic values or eigenvalues. values. Now corresponding to each eigenvalue we can have infinite number of eigenvectors. So let me calculate these eigenvectors. Now what is the definition of eigenvector? A non-zero column vector X is said to be an eigenvector of a square matrix A if it satisfies the equation A minus lambda I into X is equal to 0. This is your A minus lambda I. And now I have to take lambda equal to minus 1 and then 6. Now eigenvalue, eigenvector corresponding to the eigenvalue lambda equal to minus 1 is, let me take up lambda equal to minus 1 first, and then in the second case I will be taking lambda equal to 6. Now lambda equal to minus 1, this is the characteristic matrix. So A minus lambda I into X is equal to 0, or A minus lambda I, and lambda is minus 1. 1, okay, let me write down 1 minus lambda minus 2 minus 5 4 minus lambda into x xy equal to 0 0. Now we have taken the first case when lambda is equal to minus 1. Lambda is minus 1, so this is equal to plus 2 minus 2 minus 5 4 minus of minus 1, it is plus 5 xy equal to 0 0. Now you see this is ultimately ax equal to b, while b is 0. So in order to find the solution, or in order to find the solution, we have to make this 0. We have to find the rank. So operate twice row 2 minus 5 times row 1. What we will get? I will get 2 minus 2 0 0 xy equal 0 0. Now see, this is ax equal to b. What is the rank of a? Obviously rank of a is 1. You cannot make this diagonal element 0. So rank, there is at least one minor of order 2 which is not of order 1 which is not equal to 0. So rank of a is 1. And what about rank of AB? AB together 2 minus 2 0 0 0 0. Again rank is 1, because there is no minor of order 2 which is not equal to 0. Every minor of order 2 is 0, but there is at least one minor of order 1 which is not equal to 0. So rank is 1. So the rank is 1. So rank of A is rank of AB is 1, which is less than 2, the number of unknowns. So the system is consistent and will possess infinite solutions. This we have already done. So the system is consistent and will possess infinite solutions, which are given by this. Say this is A. So minus 2x minus 2y is equal to 0. Means x is equal to y. Let me suppose that y is k. Then x is also k. And you will see thus the eigenvector corresponding to the eigenvalue lambda equal to minus 1 is capital X, a non-zero column vector. X is said to be an eigenvector of a square matrix A if it satisfies this equation. A minus lambda into x equal to 0. Means this into x equal to 0. For different values of k, you will get different values of this x. So this is 0 0 is also a solution, but we have to find the non-zero values. K is 1, 2 and 2 and so on. Okay. So this is the eigenvector corresponding to the eigenvalue lambda equal to minus 1. Now, my another value was lambda equaled 6. When lambda equaled 6, the eigenvector corresponding to lambda equaled 6 is given by a minus lambda I into x is equal to 0. Now lambda is 6, so 1 minus 6 is minus 5, minus 2, minus 5, 4 minus 6 is minus 2. X, xy equals 0, 0. You see, let me operate row 2 minus row 1. What I will get? Minus 5, minus 2, 0, 0. Xy equals 0, 0. Now this is ax equal to b. So what's the rank of A? It is 1. Rank of AB is 1. Unknowns are 2. So rank of A is rank of AB is 1 less than 2, the number of unknowns. So the system is consistent and will possess infinite solutions which are given by this B. From B we will have minus 5x minus 2y equal to 0. So x is equal minus 2y by 2 by 5y. Okay, so let me suppose that y is k1. Then your x is minus 2 by y k1. So the eigenvector capital X, which is here minus 2 by 5 minus 2 by 5 k1, and this is k1, corresponding to the eigenvalue lambda equals 6 is given by this. So the eigenvector x is given by this, corresponding to the eigenvalue, and different values of k1 will give us different values of this eigenvector. Okay, this is it. You have to find the eigenvalues, and then corresponding to each eigenvalue you will have eigenvectors also. Fine. Next, let me take next example. Let me take A equal to a symmetric matrix. Say 2 minus 1 1 minus 1 1 2 minus 1 minus 1 2. This is a matrix of order 3 by 3. I have to find the eigenvalues and corresponding eigenvectors. Eigenvalues as well as eigenvectors for this matrix. So in order to find the eigenvalues, I have to find the characteristics equation. Now the characteristic matrix is given by A minus lambda I. What is that? 2 minus lambda minus 1 1 minus 1 2 minus 1 minus 1 2 minus lambda 1 minus 1 2 minus lambda. The characteristic matrix of A is given by the matrix. Only thing is that you have to subtract lambda in the diagonal. Okay, this you already know. So characteristic matrix of A is given by 2 minus lambda minus 1 1 minus 1 2 minus lambda minus 1, then 1 minus 1 2 minus lambda. This is the characteristic matrix. The characteristic equation is determinant of A minus lambda I equal to 0. That is determinant of 2 minus lambda minus 1 1 minus 1 2 minus lambda minus 1 1 minus 1 2 minus lambda equal to 0. Okay, I can make this 0 with respect to this, or you can just operate it. This is 2 minus lambda into 2 minus lambda square minus 1. 2 minus lambda. 2 minus lambda. 2 minus lambda is 2 minus lambda square minus 1. Minus into minus, which is plus 1. Minus 1 into 2 minus lambda. Minus 1 means plus 1. You see, minus 1 which is plus 1, plus and then minus 1, so it is plus 1. Minus 1 into 2 minus lambda, minus 1. So minus minus plus 1. Then 1 into minus minus plus 1 minus 2 minus lambda equal to 0. This into this minus this into this. So this is 2 minus lambda, lambda square plus 4 minus 4 lambda minus 1. Then lambda minus 2 plus 1. Then 1 minus 2 minus minus plus lambda equal to 0. 2 minus lambda, lambda 2 minus lambda whole square is a square plus b square minus 2ab minus 1. Then minus 2 plus lambda plus 1. Then 1 minus 2 and plus lambda. Or you can have 2 lambda square multiply by 2 first. 2 lambda square plus a. Okay, I will take one more step. 2 minus lambda, lambda square minus 4 lambda plus 3. Lambda square minus 4 lambda plus 3. Then plus lambda minus 1. Then plus lambda minus 1 equals 0. Fine. Now let me multiply by 2 first. This is 2 lambda square minus 8 lambda plus 6. Then let me multiply by minus lambda. Minus lambda cube plus 4 lambda square minus 3 lambda. Then lambda plus lambda is 2 lambda. And minus 1 and minus 1 is minus 2 equal to 0. Fine. 2 lambda square, 2 4 8 lambda, 2 3 6. Then minus lambda cube plus 4 lambda square minus 3 lambda. Then lambda plus lambda is 2 lambda and minus lambda is minus 2 lambda. Or you have minus lambda cube, this one, lambda square, 4 lambda square, it is 6 lambda square minus 8 lambda plus 2 minus 3 lambda, it is minus 11 lambda plus 2 lambda. So it is minus 9 lambda. Then 6 minus 2, it is plus 4. Okay. Minus lambda cube, 2 lambda square, 4 lambda square is 6 lambda square, minus 8 lambda, minus 3 lambda is minus 11 lambda, plus 2 lambda, it is minus 9 lambda. 6 minus 2 is 4. Or finally, the characteristic equation is lambda cube minus 6 lambda square plus 9 lambda minus 4 equal to 0. Lambda cube minus 6 lambda square plus 4 lambda minus 6. Okay, I have taken this minus out. So this is a cubic in lambda. You can see this is minus 6 minus 4 10, 9 plus 1 10. So lambda equal to 1 satisfies this equation. Let me use synthetic division. This is 1 coefficient minus 6, 9 and minus 4. 1 into 1 is 1, minus 5, 1 into minus 5 is 5, 4, 1 into 4 is 4. So lambda square, depressed equation, plus 4 equal to 0, which gives lambda equal to minus b plus minus under root of 25 minus 16, which is 9, under root which is 3 by 2. So it is 4 and 5 minus it is 1. So lambdas are 1, 1 and 4. So these are the eigenvalues. Fine. Eigenvalues. These are the eigenvalues of this matrix. Now corresponding to each eigenvalue, I have to find the eigenvector. So let me write down over here. This is the matrix. For lambdas are 1, 1 and 4. Now eigenvector corresponding to lambda equal to 1. I have lambda equal to 1, 1 and 4. So lambda equal to 1 is a minus lambda I into x equal to 0. See, this is a minus lambda I and lambda is 1. So it is given by 2 minus 1, 1 minus 1 and 1 minus 1. 2 minus 1 it is 1 minus 1, then 1 minus 1, 1. X, use x, y, z. And this is 0 matrix, this is 0, 0 and 0. And non-zero column vector. This is a column vector. Okay, now this is very easy now. This is ax equal to b. How to proceed? I have to make this 0 as well as this 0. So let me operate row 2 minus row plus row 1, row 3 minus row 1. What I will get? 1 minus 1, 1. Row 2 plus minus 1 plus minus 1 plus minus 1 plus. So this is 0, 0 and 0. Row 3 minus 1 minus 1, 0. Minus 1 plus 1, 0. 1 minus 1, 0. This is it. This is ax equal to b. Obviously rank of a is 1. Rank of ab is 1. Unknowns are 3. So rank of a is rank of ab is 1 less than 3, the number of unknowns. So system is consistent and will possess infinite solutions given by this: x minus y plus z is equal to 0. Y means x plus z. Let me suppose that x is k1 and z is k2. Your x is k1, y is k2. This is it. So column vector x is k1, k1 plus k2. This is z and this is k2. A non-zero column vector x is said to be an eigenvector of a square matrix A if it satisfies the equation A minus lambda into x equals 0. This is your x corresponding to lambda equal to 1. Similarly, you can find eigenvector corresponding to lambda equal to 4. For 4, this is 2 minus 4, 2 minus 4, 2 minus 4. Will you do it yourself or let me show this? When lambda is 4, a minus lambda I into x equals 0 means 2 minus 4, it is 2 minus 1, 1, minus 1, 2 minus 1, 1 minus 1, 2. This is x and this is 0. So operate. You can make this 0 and this 0. It doesn't matter. Whatever you like. Or let me operate row 1 minus 2 row 1, 2 row 2 plus row 1. What is that? 2 minus 1, 1. 0, 0, 0. Twice this plus this, it is 0. Twice this, it is 4. Plus this, it is 3. Twice this, so minus 2. Plus this, it is minus 1. Fine. Then 2 row 3 minus row 1. This is twice minus 2, 0. Twice, it is minus 2. So minus 1, it is minus 1. Twice row 3 is minus 2 and minus of this, which is plus 1, so it is minus 1. Twice of this, the two twos are 4, minus 1, it is 3. Now with the help of this I can make this 0, or with the help of this I can make this 0. So operate 3 times row 3 minus row 1, row 2 rather, which is 2 minus 1 1 0 3 minus 1 0. This is 3, and let me add minus 3 and plus 3, it is 0. This is thrice, which is 9, so it is 8. So you can see rank is 3. Rank of AB is 3. Numbers are known, so this is there is only a 0 solution. 0 solution of this. Because you have 8z equals 0 means z equals 0, do it. Huh? Rank of A is 3, rank of AB is 3, number of unknowns are 3. You can do it. Here comes the concept of independence and determinants. I will be sending notes to you, you will do it yourself. Okay. This is how we are able to find eigenvalues as well as eigenvectors. Fine. Let me give you one more exercise for your. This is an home assignment. A equal 2 1 1 0 1 0 1 1 2. You have to find eigenvalues and eigenvectors, lambdas and x's. You have to find these. Fine? Okay. Let me come now to Cayley-Hamilton theorem, because I will be concluding it here only. Cayley-Hamilton theorem. Statement is that every square matrix satisfies its characteristic equation. That's what? If A is a square matrix of order n, then what is the characteristic equation of A? Characteristic equation of A is given by lambda raised to power n an minus 1 lambda n minus 1 an minus 2 lambda n minus 2 plus so on a0 a1 lambda plus a0 is equal to 0. This you have seen. If you have a square matrix of order n, you will get a polynomial equation of degree n, right? By this theorem, Cayley-Hamilton theorem, every square matrix satisfies its equation, characteristic equation. Means, by Cayley-Hamilton theorem, an instead of lambda, if you put a, this will be satisfied. an minus 1 a raised to power n minus 1 an minus 2 a raised to power n minus 2 plus so on a1 a, then a0, not a0, it is a0 I, unit matrix. You cannot add a matrix and an element. It is a0 into I equals 0. This is the Cayley-Hamilton theorem. See, this is an ordinary 0. This is a polynomial and this equates to 0. This is an ordinary 0. This is a matrix now. Every square matrix satisfies its characteristic equation. It satisfies its characteristic equation. Instead of lambda, we have a. When we have added, replaced lambda by a matrix, then you have to multiply a0 by I. And this 0 is not an ordinary 0. This is a column vector 0. Right? For example, I have Just now we have done one question. 1, -2, -5 and 4. Okay. Now what's the characteristic equation? As we have seen it. I think I am running out of the space now.